Graphing linear inequalities. Before we even get started with graphing, what you need to know is the greater than symbol. And if you don't know this, you're going to have to just memorize it. You have to know what they look like. Greater than opens to the left. Less than opens to the right. They can also have greater than or equal to, less than or equal to. You must know those symbols. Now then, we're going to take these three inequalities and we are going to graph them. Problem is I only have one graph, so I'm going to use these graphs right here. So we're not going to look at that graph. Now, notice that this has got y alone. You are in slope-intercept form, which means you're ready to graph. The only difference is this says y is greater, that is that symbol, greater than. Now then, my y-intercept is -3, so I put my point. I'm going to graph. My slope is 4 over 1, so I'm going to rise 1, 2, 3, 4. Positive 1 means to go right 1. 1, 2, 3, 4, right 1. Now, when I'm graphing inequalities, the other thing you need to know, this is not an equal to, it's just greater than. So my line needs to be dashed, or not solid, whatever you want to call that, because I am not equal, so this boundary line is not included. So there's my line, my inequality. Now this says y is greater than. Greater than, you need to write this, is above. Less than is below. So when I look at this line that I have right here, I want to go greater than. That says greater than. Greater is above. Here's the line. Above it is over here. So I'm going to shade this area. All of these points satisfy that statement. For example, let's pick that point right there. -1, 1. So if I were to say 4 times -1 minus 3, because that is -1 for x, y has to be 1. -4 times -1 is -4 minus 3, so I've got 1 is greater than -7. That is a true statement. All of these points satisfy this inequality, including all the points outside the graph that are over here that we don't even have. Second problem. Notice that this one is not in slope-intercept form, so I'm going to have to make it that way. I'm going to subtract x. So 2y is less than -x plus 1. Do not combine these, they are not like terms. I'm going to divide by 2. When I do that, that is a -1. So that is a -1 half x. And this is going to be plus 1/2. And then I need to put my y and keep my symbol less than. So when I go to graph this, my y-intercept is a half. Half is just in between 1 and 0. My slope says to go down 1, so I'm going to go down in the halves, and I'm going to go right 2, 1, 2. Down 1, right 2. Again, I'm not equal to, so my line will be dashed or dotted, whatever you want to call that. It is not a solid line. And this time it says y is, that's the less than symbol. So less than is below, so below is down here. Now this problem is also right here, not in slope-intercept form. So first thing I'm going to do is subtract 2x. So I've got -y. Make sure you bring down the symbol, that is with the y. -2x plus 4. Then I have to divide by a -1, and you must flip this symbol. When you divide by a negative, this is going to change its sign, this changes its sign, this sign has to change. Negative divided by negative is a positive. 4 divided by -1 is -4. This is what I'm going to graph. Now, my y-intercept is. My slope is +2. over positive 1. This does have an equal sign, so I want to make sure that this line is solid. And when I look at this symbol, if I'm unsure, I have to look up here. This symbol is greater than, and greater than is above. So when I go back to my line, here I am, greater than is above. Above the line is over here. Now, last part of this, so that was graphing. Graph it like it's a line, and then shade. Here, how do I know if an ordered pair is a solution? Couple of ways. One is I can plug this in. Plug in 0 for x, plug in 0 for y. 0 minus 0, 4 times 0 is 0, is 0 minus 0 is just 0. So is 0 greater than 7? No, it's not. So this is not a solution. They ask right here, is 3, 5 a solution? So where I see x, I'm going to plug in a 3. Where I see y, I'll plug in a 5. This is negative 3 plus 10. And 10 minus 3 is 7. Is 7 less than 8? Yes. They can also give me a graph. So if I go back over here and I ask you about 3, negative 2, is it a solution? From a graph, 3, negative 2 is not in the shaded area, so I would say no. If they ask me about 1, 4, 1, 4, yes, it's shaded. If they ask me about a point on the line, like 2, 0, well, clearly that's on the line and it's solid, so I would say yes. But for an example over here, let's go to the top one. If they ask me about 1, 1, is it a solution? 1, 1. See how it's on the dotted line? I say no, because this is not a solid line. If they ask me about 0, 3, it is in the shaded area, so I would say yes. So they can ask me from graphs, they can ask me from equations, and when you're graphing, graph it like a line, and shade if you see greater than, less than.